So yeah, idioms are the actually low level patterns that are programming language specific. So the previous design patterns that we have seen, they are not programming language specific, right? Now, it actually describes how to implement a solution to a particular problem, right, using the features of a given programming language. So, I mean, so here the idioms are the features of a programming language itself. Okay, let's say, for example, we talk about something. Maybe there is a method we have equals to. Okay, so part of your uh, part of your programming language, so there is a feature that is called equals to. Okay, so where equals to is going to compare two different strings, maybe. Okay, going to compare two different strings, right? So what you try to do, so without thinking much about that particular implementation of that particular equals to, you keep on using that. Let's say hash code function. Maybe there is maybe iterator. You have an iterator through which you will be able to iterate certain aggregated objects, right? So these are programming language specific idioms. So you just keep them using without thinking much about their implementations, right? So they are the idioms, right? So that is what I say. So there are in English also, in the general English, so we have certain number of idioms, right, available. So what you do, you without thinking much about that, because those idioms has some meaning, like a certain number of words are combined together to form a idiom. And you keep them using in your regular speaking, right, without thinking much of about their meaning, right, because it is automatically, it's a idiom created and it is a pattern. Now this pattern is being used, okay, everywhere wherever you require, right? So that means a English speaker, so he can quickly talk many things. He do not really require to synthesize that particular thing again. So he just can speak out by using those idioms. Similarly, here also programming also there are idioms, so we keep on using them. So we will not think about much. Like let's say in the part of your math class, okay, maybe there is a function called method called sort. Okay, so whenever you want sorting, so what you will do, you will use math.sort function and you pass on the array into the sort function, then automatically it is going to give you going to return you a the array with sorted elements. Okay, so this is the way that you can use certain idioms, and these idioms are very specific to a programming language. That means the programming language already provided you these. Okay, so there are also some patterns. Okay. And in the last lecture, we have seen about creational pattern, that is through an example of what factory method we have seen, right? So it exactly reduces the bug detection and correction iterations, right? When you are using it, idiom, so you need not be again required to correct those things, because usually idioms they come with error free. Okay, so that is the reason why you can without thinking much about the error, okay, or the bug, or the so you can keep them, you can use them in your program, right? In contrast to algorithms, patterns are more concerned with aspects such as maintainability and ease of development, right? So why we use these patterns? Because we wanted to make our software easy to maintain and easy to develop. That is what the objective, right? But when you talk about in algorithms, right, algorithms are also what? So you have existing algorithms, right? Whenever I say sorting, so you can take any of the existing algorithm without thinking much about them. So you can implement those algorithms, right? But algorithms are what? So they actually their objective is to give you the best in terms of space and time complexity. Okay, but here the patterns are usually with the objective of maintainability and development, ease of development, right? So this is only the difference, but so you can get an idea now. So both are reusable, like there are algorithms you have developed, so you can use them, right? Let's say Dijkstra algorithm. Okay, so Dijkstra algorithm is the one which is going to give you shortest source to destination path. Okay, Now, without thinking much about digital algorithm, you can use them, right? So why these algorithms are existing? Because we wanted to reuse those solutions. Wherever you need a shortest path sort of, I mean, wherever you want a solution to a problem where you need to find the shortest path, you will be directly going and using your digital algorithm, right? Maybe you will be using Bellman fold algorithm, right? Maybe so this way you will be keep on using some algorithms, right? Similarly, here is also patterns. So you have a certain number of patterns, and wherever you find such sort of pattern problems, so you will use those patterns. For those patterns, there are solutions. So you will use them. That is what our objective, right? So algorithms primarily focus on solving problems with reduced space and time. That is what I said you, right? So algorithms, they have an objective of giving. So algorithms are they have been developed with the intent to reduce the space and time complexity, right? So where patterns focus the understandability and maintainability, right? That means it should be very easy to develop, because if you understand, then you can easy to develop, as well as maintainability means so you can easily maintain the software at later point of time whenever you want to. How you can maintain. Now, there are certain pros and cons associated with design patterns, right? So here, so you have once there are certain number of strengths, right? So that means it exactly provide a common vocabulary that helps to improve the communication about the developers, right? So let's say, for example, there is a pattern today we talked about the factory method, right? So now the factory method, so it is a common vocabulary. So that factory method approach, if it is identified as a pattern, then I know, and someone else also know the factory method, so they can also use, right? So wherever I see similar sort of things, I can identify that it is a factory method, right? So that means it stands as a common vocabulary. That means everybody can understand that, and now it will have a same meaning, right? So like the idioms also, right? So it is a common vocabulary. Idioms are also, right? So help to capture, disseminate expert knowledge, right? So through these design patterns, you will be able to actually um, first thing that you will be able to capture, as well as you will be able to disseminate this knowledge. That means that is the strength, I mean design patterns. Okay, so they are the knowledge. Actually, as I told you, they are based upon the experience. Okay, so developers, based upon the developers experience, so we have come up with the sort of patterns, and these patterns will be commonly reused. Okay, that means it will be disseminated throughout the development industry, so that everybody can use that sort of patterns, which will help them to write their code very quickly, right? Help designers to produce designs that are flexible, efficient, and easily maintainable. That is what the objective of it. Okay, so guide developers to arrive at correct design decisions and help to improve the quality of the design. Okay, so because you at the end, so you will come up with very bug-free designs. Okay, because you have taken the best decisions, because you have given the best solutions, design solutions, right? And as a result, definitely it will improve the quality of the design. Okay, so now the main advantages here is, so the reduce the number of design iterations and help improve the designer productivity. So as a result, so because you see, so the very fast, if you're going through certain patterns, so definitely, so your development is the design is very good, right? And it does not leave any bugs. So as a result, so you do not require to go and again and then again look back into the design. Okay, so that is not required. That means you do not going through certain iterations of the design, right? So as a result, definitely it will improve the designer productivity. That means you will be able to come up with quickly you will be able to come up with the design very quickly. Okay. Now, there are some disadvantages with the design patterns. What are they? So the first is design patterns do not directly lead to code reuse. Okay, so that means, so actually whatever the design patterns that we see, so so usually you'll not be able to, once if you have identified this design pattern, so you cannot directly go into code reuse. Okay, so only thing is that what you will be doing, so you will be applying this concept or the idea. Okay, let's say for example, I told you what I told you about adding new class into the class library. That one example, right? Maybe 3 vehicle, 4 vehicle, 2 vehicle, 4 vehicle class was there. So you wanted to add that 3 vehicle class, and after which, so if you use factory method, you do not really need to make many changes in the client side, client code. Okay, so that is what we have seen. But this is one idea. Okay, this is what we try to apply this pattern. But can you see that, if I say this two-wheeler, four-wheeler case, can it be same thing? Can it be factory method? Can it be used in some other project? You cannot directly use the code. Okay, because so it is the code for the vehicle only written. Maybe you have some other problem domain where you have aeroplanes. Okay, so there, let's say you have a maybe two wheel aeroplane, three-wheel aeroplane, four-wheel aeroplane, or something like that you can think of. Okay, now so in that case you cannot directly add this code, I mean reuse this code. Only you, what you can do is you will be able to apply these design patterns. Okay, so that means you are not able to directly make the code reuse, but your design is happening here. Okay, you are reusing the designs. Okay, it's not the related to code. Okay, so that is the no, the drawback you can think of. No methodology is available that can be used to select the right design patterns at the right point during a design exercise. Okay, so even there is there is no such methodology today, which can tell you that which particular design pattern should be used at the during maybe you are developing the designs. Okay, so that is or exercising the designs, right, at that point of time. It is all based upon the experience, right? So if I am a good experienced programmer and I have a good knowledge about these patterns, and I can think of, right, for this particular problem area, maybe this is the pattern should be used. Okay, but there is no specific methodology. That means you have to use this design pattern, otherwise your code will not work. Is it like this? No, because we have seen without without using design patterns also you can write the code. Okay, so a programmer who prefers to write his code without using any design patterns, that means he don't want to use a factory method. He can simply write, he can go with the if else way only, right? Do you understand? So it is there is no such methodology. Methodology means you have to use it. Okay, I mean, as we have seen our data flow diagrams, or maybe you have seen the UML diagrams where you follow some methodology, right? So you have to have a rectangle, you have to place, if there is a class, then you have to add this class. Methodology by which we apply. So here we do not have any methodology for these design patterns. That is what. Now there is a concept called anti-pattern. Now we have seen the pattern. Now there is an anti-pattern also available. Okay, so now what is this anti-pattern? So this actually usually the anti-patterns through which we try to represent the lessons that we learned from a bad design. Okay, that means anti-patterns are the ones actually which captures the bad design. Okay, so it always if you identified certain bad designs, so now they can be placed as an anti-pattern, and at any point of time, if you find this pattern in your program, then you can easily you can easily remove that particular pattern, right, as a result, because that's a very bad design. Okay, so we should know, and we have gone through some good design. Now we should know also some bad designs, right? So that is what captured through anti-pattern, right? So there are two popular anti-patterns, right? So that, I mean, those that describe bad solution to problems which leads to a bad situation, those that describe how to avoid bad solutions to problems. So there are two ways. Okay, so some anti-patterns, they try to describe that these are the very bad solutions Okay, if you apply them, so probably you will be end up with a very bad situation. And there are some anti-patterns which will describe always how you can avoid those bad solutions. That means you need to avoid those bad solutions. That means you will be going towards better solutions actually. Okay, so there are two ways. Okay. Now, so there are some interesting anti-patterns. So one is this input class. Okay, so this concerns failing to specify and implement a mechanism for handling invalid inputs. Okay, so that means you can think of one anti-pattern where this is something like this. Okay, so where fail to address a mechanism for handling the invalid inputs. Okay, if you, let's say for example, if you give a invalid input to the system, what will happen, how this system will react. Okay, let's say for example, I can say something like so you developing a calculator. Okay, now and for that particular calculator, so you can always have a division functionality, right? So now let's say for example, if you give 10 20, what will happen? Or if you give 20 10, so if you give to the division functionality, it will give you what? 20 by 10 is equal to 2. Okay, it will give you. Now if somebody gave, instead of 20 by 10, somebody has given input something like this, 100 and 0. So what will happen? So 100 by 0 is nothing but a invalid, right? So it's a infinity. Now whether they actually handle that or that particular things or not. So usually we fail to, whenever you fail to address those things, so they are these things are called as, these sort of the anti patterns are called as input class. Okay, input class. Okay, so that means it is all related to invalid input. Okay. And there is a magic push button, right? So some programmers, what they try to do, let's say that you have created a push button GUI. Okay, so push button is a class, right? That means it has certain methods, right? Now you try to put your logic inside that push button class. So that is what actually we do not do. What we do is, so push button is a class, we try to use that only it will have its own certain number of methods, right? So the methods, one can be used to increase the width of that button, or maybe you will be able to increase the text size, maybe the font of that particular push button text, or you wanted to give some what you say, strokes to that particular push button, right? Or you, so there are many things, right? Maybe you wanted to give the background color for that particular push button. So there are methods already there, right? But we do not so when you push that particular button, what action should be taken place, that sort of action or the logic should not be written part of this push button, okay, class. If you are writing them, I think it's a very design. Okay, so you should always know whatever the logic that you need to be performed after pushing this button, so those things should be written in a separate class. Okay, so these sort of patterns are called as magic push button. And there is a race hazard. Okay, so they are concerned failing to see the consequences of all the different orders in which events take place in a practice, right? So I mean, maybe so you may not have taken into this consideration, right? So whenever people carry out certain events, right? So maybe order is also important. So you may not have that taken into account, that in which particular order these events will take place, right? So if you failing to address that particular issue, so then it is called as race hazard. Okay, so now these are few interesting anti-patterns. So there are many, so you can go through and you can understand if you have more interest in this, right? Now we'll see some example of these patterns. So right, so here any doubts of our students?
No, sir.
Okay.
No, sir.
No, sir.
That means everything is, I can assume, right? You all understand everything. Is it that? Or no? Can anyone? Okay, right. So I can assume, so you understand everything. Okay. So then there is something we will see about some example of these patterns also, right? One example may be the expert kind. Okay, so what is this expert kind? So which class should be responsible for doing certain things? Okay, I mean, so these are the patterns, something like this. Okay, the problem here is, so I mean, you have certain responsibilities, right? You know always what is the responsibility. We have already talked about that during class, CRC cards, right? So I told you, right? So each and every class is assigned some responsibility and along with the collaborator. So we talked about that, right? So you understand responsibility is something like the methods. Okay. So now what are the some responsibilities a class particularly going to going to take up, right? So those things, that is also a problem, right? So that means that is also a problem, right? Now for this, the what would be the solution? Assign responsibility to the class that has the information necessary to fulfill the required responsibility. So one expert pattern is something like this. So somebody will say that, so I mean, you should assign a responsibility to a particular class. So that class should be able to provide you all information necessary to execute that particular responsibility. Okay. Do you understand what I'm trying to say? Let's say you have a class. Within that particular class, you have an attribute 1 and 2. Okay. Right. And you try to develop a method. Okay. If that particular method is not going to use these two attributes, what it means? If that particular method, whenever it wants to execute that particular method, right, it requires some information, data, right? But those data are not available with this class. I mean, these two attributes are not being used by that particular methods. Okay, methods in that class. Then maybe you need those attributes from some other class, right? That means you going to borrow those data item. I mean, maybe you will be going through inheritance, or you may be going to using the friend class, okay, concept in C++, right? So by which you will be calling getting those attributes, right? Now what is happening here? So why then you assign that particular responsibility to that class where you do not have the data to act on, right? Then better you should place that particular responsibility to the class in which that particular data is available. So then otherwise unnecessarily you increasing the communications, right? So this is one pattern, right? So you should always assign the responsibility to the classes that has the information necessary, right? Then only it is good. Okay. So something like this. Okay. So here is an example of a class diagram. Let's say so you try to assign some of this, right? So sales transaction, sale item, right? And then item specification, right? So you can understand by this diagram. So you have a specifications the items, right? And this is what exactly associated with the sale item, and then the sale item is actually a kind of aggregation, right, with the sale transaction. Okay, I mean whatever the sale transaction you have, so that will be part of this sale item. I mean that has a part of that will be a part of this sale item, right? Now, so you try to assign some of this responsibility to those classes based upon what data it has actually. Okay, so that is what exactly we try to do, right? So otherwise you will be going to have this sort of collaboration diagram. Maybe you will be talking, so let's say price related, right? So price related information will be associated with what? So will be associated with the item only. Okay. So or item specification, right? So whether if you want to take a item with a higher specification, the price will accordingly increase, right? If you have specific with low specifications, I mean very few number of specifications are required, maybe they are not, so the price will actually vary according to the specification, right? Now this particular class has the information of price, okay. So this way you can think of, right? So you should assign the responsibility to the classes. That particular class should be able to get those informations, right? If they are not getting able to get those informations, then probably you should not assign the responsibility to that particular class. Okay, so this is what an expert pattern is all about. Now there is another example here, creator. Okay, so what is a creator pattern? So which class should be responsible for creating a new instance of some class? Okay, so now there may be situations, you always know whenever you have one class, so part of that particular class constructor, so you can always create the instances of some other class, okay. Because you wanted to use that other class also, right? So then you need to create an instance, right? So if that such a situation comes, then so which particular class should be responsible for creating a new instance, okay, right? So this is because it is all creator, that means it is all related with related to creation of something, right? That means creation of objects here or the new instances here, right? So assign a class C1 the responsibility to create class C2 if C1 is an aggregate of objects of type C2. Okay, so that means what it says now, C1 and C2, okay, they are the two objects, right? So if C1 is a aggregation object of C2, okay, that means C1 and C2 both are aggregated, right? Or that means you can think of like this, maybe C1 contains the object C2, okay, then only, so the C1 is usually used to allow to create the instance for the C2 class, okay. Otherwise you should not create, okay. If they are independent, so they do not really require to aggregate something, so then why you need to create an object? So you shouldn't create the objects for other class, okay. So when so this is one solution, okay. So problem is that who should create and are responsible for creating the instances, right? This is one pattern, right? So there can be another pattern called controller. So let's say, for example, it is all related to the GUI things, right? So who should be responsible for handling the actor request, right? So that means actor is the one who is going to use the system, right? He is the one who is going to give some request to the system, right? So he is the one who is going to interact with the system. So whenever actor is giving some request to the system, now who is going to who is going to handle these requests, right? Who is responsible for handling that particular request, right? So this is what, right? So the main solution here is what I already told you before also. So usually for each and every use case, you can have some objects, right? You can have some classes, right? Per user use case pair, okay? So you can have a separate class, right? And that is what we say. Sometimes it can be a separate controller object, okay? You can have a separate controller object, okay, which can control all these sort of things, right? So that means you can have a separate controller object for each of the use cases. So that is the way that, because the user is going to interact with the use case only, right? So now then you should have one separate controller object for that, okay, for each and every actor. Now there is another pattern where we can say it's a facade, okay. So here, it is all, if you understand, if you know the concepts of adapter class, okay, if you know the adapter classes in Java, so you can easily understand them, okay. Or you can, if you know the wrapper classes, how many of you know the wrapper classes in C++? Wrapper or Java, in Java's wrapper classes. Anyone here knows what is a wrapper class?
Integer classes for small length.
Yeah.
Sir,
Yes, yes.
for primitive data to non-primitive data conversion.
Right. So now understand, right? Wrapper means, so so some sort of class is converted or interface is converted into some other type of class. Okay, maybe you might have seen something like this. So you have a simple primitive data type integer and you have converted that into a object class type, right? So maybe you converted that into capital integer, right? So that is one wrapper class, right? So there can be many. I mean, why these wrapper classes? So the wrapper classes are the ones so being used to provide some services to the customer. Okay, I mean, let's say we don't want to give all the internal details, right? So then what you do, we create some wrapper classes. Okay, and I mean those wrapper classes, you see, you can have a very large system, right? And in part of large system you have a very large class. Okay, large number of classes, right? Now suddenly is you create some class, okay, which is going to different number of classes also you can think of. That is what we call as adapter classes, right? So now through adapter classes you will be going to actually interact. You are not directly interacting those classes, but you will be, you know, talking to this adapter classes through which you talking to the number of classes that you have. Okay. So, I mean, this is what exactly called as an adapter class, right? You can think of. So now that could be one example here, Fakat, right? So what you do here is, so maybe the problem here is a package because you will have a very cohesive set of classes. So all of these classes can be, can be combined together to make as a package, right? And you will be actually using that particular package. Okay, so this is one example. That is example for this is the problem. I mean, as I told you, so you have a, let's say, graphical user interfaces, right? So as part of Java, so there is a package called swings. Okay, there is a package called swing. That means all of the cohesive setup, that means the related set of classes, they will be part of that particular package. Now you can directly use whatever the class from that particular package only. Okay, so if they are, if you don't do grouping them, I mean, then probably. So that is what we provide an interface through which you will be able to access all of the GUI things, GUI classes, right? So that is what a adapter or a wrapping things. Okay, so now you can understand. So RDBMS interface package, right? So similarly, it is all related to a database. Okay, you can have some interface package. So a solution here is a class database packet. Maybe for the database interface you can create a database packet, can be created with which provides a common interface to services of package. Okay, so that means through an interface you will be able to use all of these classes, right? So now what I said, so you can simply use a primitive data type, maybe small integer, through what? Through a integer class. Okay, that means you are not directly going to talk to the integer primitive data, but you will be talking to through a wrapper class. Okay, that means some other class covering this particular small data, data type. Okay, do you understand? So wrapper is something. So you have a set of classes above which you create another wrapper. Okay. So now through that particular wrapper, you will be talking to each and every one, whatever that part of, right? So this is what exactly a pattern also, right? That is what packet. Okay. Now you can understand from this diagram also. Is this diagram is visible to you all?
Yes, sir.
Yes, sir.
Okay. Now you see the left side is something we are not using a facade class. Facade means adapter class. Okay. So now you can see. So you have let's say there is a service package. Okay. Part of this you have a 4 classes, right? Now, so everyone now outside of this package, they directly going and talking to those classes. Okay, you can understand. You see there are 4 classes within the package and there are 4 classes outside the package, and those classes let's say the class number 1 is going wants to interact with a particular class, so he is going directly and interacting with this. That means so the service invocation without using a facade class here. Now the same thing that what we will do now, you see the right hand side we are using facade class. That means what, you have these all different 4 classes and then you create one facade class. Okay, now every other classes will be interacting to those classes through the packet class. Okay, whenever a particular outside class wants to get some invocation or wants to get some service, so he will try to, that particular class will try to access these classes through a facade class. That is what we call as adapter class. Also in example, you if you do not understand much, you go and see some example of adapter class in C++ or Java. Okay, then you can understand, right? So through which we will try to use. So this is also a good pattern, right? Whether each and every class is going to talk to know about all of these things. So better we should be knowing about only the facade class through which we can get all of the services. Okay, so whatever the services we wanted to get, you try to get through this facade class only. That is what the facade thing is all about, right? So now there is something called model view separation patterns, right? So here we try to discuss about some of this pattern which is related to maybe the GUI things when you have a graphical user interface sort of things, right? So now what you try to do? So you need to, problem here is you need to separate your non-GUI classes from the GUI classes. Okay, that means the classes which are related to the graphical user interfaces and the classes that are related to some processings, they are not part of the graphical things, so should be separated out. So this is what exactly a model view separation pattern. So problem here is this. Okay, now the context in which problem occurs. So this is commonly occurring a problem. So it is mostly, you see, whenever you develop any software, mostly the softwares come up with some sort of GUI, right? And then so view means what? View means through which you try to see interact your GUI objects, right? So through which you will be able to see your GUI objects, right? Let's say push button. Push button is a GUI object, right? Or maybe you menu selection is a GUI object, right? So these are all part of view. Okay. A model is model actually represents the domain layer. That means they are not the GUI objects. They are the objects they involve in executing the logics or the implementing the logics of the business process, right? So they are related to the model, right? Now what we are trying to do, we are trying to separate out the GUI objects from non-GUI objects, 32 are. Okay, so the domain layer objects are responsible for providing the required services, whereas the presentation layer objects are responsible for handling only the interaction with the user, right? So you can understand now. So domain layer is what, presentation layer is what, right? So your view is the presentation layer, domain layer is the actually the model, represents model, right? So through model objects you get actually the service. Okay, but through your object presentation objects, so you only get the interactions. Okay, I mean the user is going to interact with these objects to get some services from the system, right? So that is what exactly called as a model view separation patterns, right? So the solutions here is, so that depending on the context, solution provided by either of the observer pattern, model view controller, or the publish subscriber pattern can be used. Okay, so solution is, so that means you have many such sort of view model separation patterns, right? So depending on a particular context, you need to make use of these patterns. So there is a observer pattern, there is a model view controller, MVC pattern. Okay, sometimes we call MVC architecture, So and there is a publish subscriber pattern, publish subscribe pattern. Okay, so these can be used depending upon your context where that particular design pattern is suitable, right? So the explanation here is, so the main idea is to achieve loose coupling between the model and view object. That means you wanted to create a loose coupling, okay, between the model and view objects. Okay, we wanted to separate them. Okay, separate them means they will be interacting, okay, but you shouldn't make them very cohesive objects, okay. So otherwise what will happen, the system complexity will increase, right, and we'll see things, right, so that the complexity of the design is reduced and reuse of the model objects can be enhanced. That means you can easily no, reuse them, right, that is what. And there is a, as I told you, so you can have certainly patterns. One is a observer pattern, right, as I told you. It's a pattern related to model view separation, right. So then what is a observer pattern, right? How should the interactions between the model and view objects be structured? Okay, when a model object is assessed by several view objects, okay, so that means it is all related to, I mean, you can see, so you should be able to, I mean how you will be able to structure them, all of these objects, right? So because there are several view objects, and these several view objects, that means you see there are menu button, there are push button, there are text area, there are insert button, there are, you know, so many, there are radio button, there is a scroll bar, there is something, you know, there are many objects through which a user is going to interact, right? So now, so when these all different objects, you know, trying to access a model object, right? So then how these interactions should be modeled, okay, how you can model these all interactions between the model view objects be structured. So that is what exactly related to observer pattern, because observer means someone who is you know, trying to access or trying to see that particular model object through several view objects. That is what, right? So the observer should register themselves with a model object. That means, so the first thing is that the observers who is going to actually access that particular model object, right, or use that particular model object, are, that means wanting to get some services from the system, so they should first register themselves with the model object, okay. Now model object maintains a list of all registered observers, right, so that when a change occurs to a model object, so you to notify all the registered observers, right. So that means what will happen, so because as I told you, there are many view objects, they are accessing the model object. That means the model object changes its state. That means it is no, data, because it is carrying out certain processings, right? Accordingly, the view is changing, right? The data is changing. When the data is changing, that means these information should be reflected to the all the view objects, because view objects also should be able to see them, get them reflected, okay, whatever the changes are happened, so that should be reflected through some view objects, right? So like you see what is happening, let's say if you have you have given some data and then you pushed a insert button. When you push that, you know, submit button, let's say submit button, okay, when you given this submit button, what will happen, if your data is being taken up and then processed and they are stored in a database, and after that some information is given back to the view objects, right? That means maybe the data that you submitted has been successfully stored with the database. This sort of information you are giving back to the display or the views, right? So that means whoever the views that are associated with a particular model object, so they should be notified, okay, they should be notified this information that there is a change in the model object, right? So this is what exactly, unless or until these observers are actually you know, registered with that model object, so they will not actually, the model object cannot you know, notify them. That is the reason why, so there should be a pattern. So this is a way that, you know, there should be some sort of a registration process should be there, right? So that is what we say about observer pattern, right? So each observer can then query the model object to get any specific information about the changes that might require, okay. So that means there is a way also, right? Even at any point of time, any observer, okay, he wants to know what is the data or the what is the change that happened with the model object, so he can query also. And there are two ways that can be handled. One is may it use push or pull models. That means push means, so something like this. Pull means what? So you try to pull the information. The information is available with the model object. Now you try to pull them. And that something else is maybe the model object push the data towards the each observer. So there are two ways. I means either the observer can request or the model object so notify even if the observer has not asked for, so it will try to push the data to the each and every observer, right? So this way you can model them, right? So the interaction diagram is shown in the next slide. Now you can see one interaction diagram based upon this, right? How it is happening. Now you can see there is a model here in the model and you have a subscriber. Okay, let's say these are the two subscribers. They are going to use this particular model objects, right? So then what will happen? So one thing is that so first the subscriber is going to register with the model. Similarly, subscriber 2 is also going to register with the model. Now if anything has been changed in the model object, so this will be notified accordingly. So that first the model object 1 will notify to the subscriber, as well as it is also notifying the information that this has been changed in the model object, right? So this is what the way that the model things work, right? So the observer pattern has the following limitations, right? The model objects incur a substantial overhead to support the registration of observer and also to be responding to queries from the observer. That means definitely you can find so this is a overhead, right? So there should be a registration support as well as responding to the queries whenever asking. So it takes some extra overhead. So this is a substantial overhead that you can understand, communication overhead. Okay, so the two-stage process or notification and query reduces coupling between the model and observer objects, right? So what will happen? But when you use them, this notification and query process, as a result, what we are doing, you are actually separating out. That means we are model and observer things. So we try to loosely couple them. Okay, so if they are tightly coupled, then we probably instead of notification things or the query things, so maybe you will be able to call those methods. Okay, as a result, you will not have the loose coupling. So you will be going to get the tight coupling. But through this, we will be able to separate them out. So we can able to loosely couple them. Okay. So now there is a model view so controller where so how these GUI objects they are going to talk to the model objects, right? So this is all related to model view controller, right? So here the problem is how should the GUI objects interact with the model objects? I mean, whether they should directly talk to the model object or they should talk to the controller first and then controller is going to talk to the model. So this is what the question, right? So this is a problem. This is what this sort of problem is called as model view controller. Okay. So the solution here is GUI objects need to be separated into view and controller types. Okay, so that means whatever the objects that you have, they should be separated from the model objects like a view as well as controller types. Okay, so this pattern is useful in applications in which the model object can change its state asynchronously and multiple consistent views of the model objects are to be handled effectively. Okay, so that is what I said you also, right? So you have a model object, right? And you have the observer objects or the GUI objects, right? Now, so these GUI objects are talking to what? This model object. Now, if you do not separate out, right, GUI objects and model objects, what will happen? So the model object cannot work asynchronously. Okay. So that has to be some sort of synchronously that has to work. But now what will happen, because you have so many objects, now these so many objects, they can be talking to the model object separately. That is what possible, right? So that means you can have some sort of concurrency, right? You can have some sort of concurrency here, right? So these objects can be talking to. So this is possible with the model view controller pattern, right? So one example here is something like this. Okay, so you are maybe something like this. So view what will happen? So the view object may be going to talk, maybe going to talk with the controller object, and then controller object may be going to talk with the model object, and then model object may be giving notification to the controller, and controller may be in turn talking about a view. Or you can see now here something like this. Okay, so controller object is doing certain updates to the model object. Now this model object is what? Giving notification to the first, giving notification to the controller, and after that, at the same time the model object is also notifying to the view one. Okay, so that means you trying to separate out the controller, view and model. So view is most of GUI related. Okay, do you understand now? And the controller objects are the ones who is going to direct the request of the views to the model. So this is what exactly you can see one example of this model view pattern. Okay, so something you can take up as a example, right? You have the same data, but you want something like this. You want the line plot, you want the bar chart, you want the pie chart. So you have the same input data, but you want different representations, right? So that is what we say, right? So you have so the same data, but you want different views, okay, of that particular, what you say, data, right? So this sort of things can be in an example for this, okay, to understand this model view. Now there is something called publish subscriber pattern. Okay, so this pattern is more general form of observer pattern and overcomes many of the shortcomings of observer pattern. Let's say we see what is that problem. So when a given model object is accessed by a large number of view objects, okay, so the model state changes asynchronously. How should the interaction be structured? Now, as I told you, so you have a model object which will be accessed by many view objects, right? And at the same time, this model object is going to change its state, okay, asynchronously, right? That means it is keep on changing its state. Now, then how these interactions can be, structured? This is the other way. This is another issue of publish subscriber approach, right? So here, what you do is the solution here is the pattern suggests that an event notification system should be implemented through which the publisher. Okay, so there is a something called publish and subscriber. Can anyone tell me what is a publish subscriber? Can you, what you understand about this publish and subscriber thing? Where you do this sort of publish and subscriber?
Sir, it's like a newspaper, sir.
Hmm?
Newspaper agency publish the and we all subscribe.
Which example you are talking about?
Sir, like Times of India, any newspaper, sir.
Right. Okay. Right. So that means what you try to do, you can think of this. So nowadays, in IoT is also people are coming up with this architecture, publish, subscriber, right? That is what you call as MQTT. This sort of protocols are there, application protocols, right? So here you can see now what you are trying to say is you subscribe to something whenever there is a data changes. Now these data changes will be notified to you all, right? Now you can see about Twitter, okay, where so they also have this publish subscriber thing, right? You now following someone, right? Then what will happen when you following someone? If whatever the activities he is doing, now those information is coming back to you. Okay, that means you subscribed to someone's profile, right? So then whatever the informations he makes or he creates or he updates, so those things will be pushed to you, right? So this way, right? So instead of, as I told you, so whenever a model changes its all state, if we follow this publish subscriber architecture, what will happen? That information will be notified to all of these subscribed objects. Okay, so this is what we call as a publish subscribe system, right? So you have a model object one, and you see, so there is a event manager in between, right? Now this, through this particular event manager, so he is all doing all this thing, right? So whatever the model object one changes its state, so it is just publishing, and whoever the GUI objects are subscribing to this model object, so they all getting the notifications, right? So this is what we call it. So here you can have n number of model objects and n number of GUI objects, and they can subscribe to any of these model objects and they can get the data, right? So this is what exactly a design pattern, right? So you can see action diagram. Here you have a model object, there is a event manager. Okay, so now the model one is publishing through a event manager, and all of the subscribers, they are going to get the data from this event manager. Okay, so this is all about the publish subscriber, right? So we'll talk about the rest maybe in the next lecture, because you have another lecture, so you need to switch. Any doubts so far quickly? Any doubts, students? No doubt. Anyone? Tell me just. Is there any doubt?
No, sir.
No, sir.
Okay.
No, sir.
Yeah.